TheTokener explains. Beginner's Guide to Developing Smart Contracts using the Solidity programming language on top of the Ethereum blockchain platform. In this episode, we will be talking about conditional statements. These are very important to be able to only execute some code when some expression is true. And Solidity is very similar with this in this regard with relation to other programming languages, which means that I will go through the theory very quickly, and then we will be updating the smart contract we've been writing in episodes 2 and 3 to see how this works in practice. Now, the core conditional statement in Ethereum is the if-else statement, and this works exactly the same as in languages like JavaScript or C or other C-like languages, in that you write an expression that evaluates to a boolean inside these parentheses, and then inside this block you can write one or multiple lines of code, and these will only be executed when the expression is true. And if you have something you want to execute when the expression is false, you can also pass the else keyword with another block with one or multiple lines, and those will be executed all the time when these are not executed and the other way around. Now, the only difference between JavaScript, C, etc. and Solidity is that in Solidity the expressions really need to evaluate to booleans. In JavaScript and in C there are some implicit conversions happening, and in Solidity you need to do those conversions explicitly, manually, if you really want them to happen, and otherwise only simply use booleans for your expression. Now, to perform comparisons or other things that are interesting to check if you want to execute one half or the other half of your code, Solidity supports the very basic equality and inequality operations and comparison operators that you might very well know from other languages. They work exactly the same in Solidity. It's important to note that the logical AND and the logical OR are short-circuiting, which means that the right operand, so in these examples B and D, are only evaluated whenever A for AND is true, or C when you use an OR operator is false. If you're writing yourself, if you're writing code, don't rely on this because it makes code hard to read. There's almost always a better way to write your code that does not have to depend on short-circuiting, and the compiler is smart enough to optimize it in any way it can. But if you're new to these kinds of languages or new to Solidity, I did want to make sure that you know that this is happening because you might encounter it in a smart contract that someone else wrote. Solidity has also support for ternary expressions. Again, this is something I think programmers should not write too often, because almost always you can write a ternary expression in a way more readable way by giving it a name and wrapping it in a function. In this example, for instance, we check if x is larger than 0 and return the negative value if it is smaller. Of course, this is a very common operation to compute the absolute value, and it's a lot clearer if it is written like this and we have a function somewhere that does the same thing. So these two pieces of code perform exactly the same operation, but in my opinion the second one is a lot more clear to whomever is reading your code. And that's important, of course, because it makes your code less likely to contain bugs, and because we cannot ever upgrade smart contracts, it's very important that your code is bug-free. Then finally, a small piece of advice: when you put a lot of different conditionals inside one another, the code goes to write further and further, and at some point it's very difficult to see if we're still inside the if part or in the else part of some condition, and very often you can write your code a little bit in a different way by returning if, so write the error case first and returning whenever those occur, and this means your code is not going further and further to the right. So once again, if you do all the error handling with if else, if else, if else, then all your actual code is in here, and you probably have some return statements down here as well. But if you are able to rewrite your code like this, it becomes a lot easier to read. Now, Solidity has also a very special feature known as function modifiers that are able to take common if expressions, common checks you do before your code, before a function is called, and wrap those functions with those checks. And this makes your code even easier to read and even shorter. And we will be talking about function modifiers in a future episode, a couple of episodes down the line. And then very common when we are handling errors that user tries to call something on a smart contract, and they provide arguments to the functions that do not make sense. We're able to stop executing the smart contract with the keywords assert or require. And we will be talking about those actually in the next upcoming episode. But for now, let's just use the basic if-else statement and update our smart contract. So what we had at the end of episode 3 was this piece of code, and let me actually show that to you in our Remix smart contract development environment. Here we go. Let me actually make the code a little bit bigger. That's very big now, the screen. Yeah, okay. So like this, you can probably easily read the text. We can move that out of the way. So this is the file we ended up with at the end of episode 3, which is a very simple contract, and we can read out the current message that's in there and change the message by passing it a new value. However, if we were to deploy this to a real blockchain, then anyone who knows the address that it is deployed to is able to change what message is stored inside. And of course, it will be nicer if we can restrict access to changing the message to be only ourselves, for instance, so only the person who actually made the contract uploaded the contract in the first place. So that is what we are going to do. And for that, we're going to use the knowledge of the last, so this episode and the previous one. First, we need to track who was actually the person that uploaded the smart contract, and we will do this by introducing a variable called owner, and this is of the type address because we want to keep track of the address of the person who uploaded it. Now we will introduce a constructor, and I haven't talked about constructors yet, but is a function that is automatically called when the contract is deployed, and you can use this to set some default values to the messages, to the variables in your contract right away. And you create a constructor using the constructor keyword and give it some parentheses. We will be talking more about this in the future. For now, we don't put anything in here because we don't pass on any arguments to the constructor. And in the body of the constructor, we will be setting owner to be the message.sender, which is a special operation that allows us to check who the person is. So what the address is of the person, or possibly another smart contract that is executing the current call. So when the constructor is called, the current call is creating the smart contract. However, when the message is changed, we are also going to check the message.sender, because then that is the person that attempts to change the message, so the address of that person. So here we introduce an if statement, and in the expression we will check if the message.sender is equal to the owner of the smart contract. And if that is true, then we will set the message to its nil value, and if not, we will just do nothing. Alright, I believe this is enough. We can keep the basic message as it is, or we could also put it over here. Message is I like cookies, and remove it over here. The result will be the same. And let's compile it and then run it using the JavaScript VM again. So we deployed the contract, and now because I'm zoomed out so much, we won't actually see the stuff down here. Let me move it up a little bit. Here we see it has been deployed, creation pending, and it has been deployed. So now we can here look at this first contract, and we can look at the current value by clicking on message, and we see here that the message is I like cookies, and we can change the message by typing a new message in here and clicking that button. And now if you check it again, it has changed. So the normal way of changing the message still works. But now when we change what person, so what address is attempting to change the message, so we change here from the topmost address to the next one, then if we try to, so we can still read out the message then, as you can see we call it and it returns the value, which is still the same. But if we try to alter it, I am way cooler, and we try to change it, then the call will execute. But if we check what the message now is, it is still the original message. So in this way we were able to make sure that only the owner, so the original creator of the smart contract, was able to alter the value that is stored inside. That was it for this episode. Leave us a comment, like, subscribe, and ring the notification bell to know whenever new episodes appear. TheTokener Explains is a collaboration between TheTokener and Resilia. If you're interested in the latest cryptocurrency related information and news, go to TheTokener.com. And if you're building your own blockchain related product and have some questions or would like some help, reach out to us at resilia.nl.